In 2019, a laboratory at Harvard Medical School took delivery of 61 bone samples excavated from a cemetery in the Indian state of Haryana. Every one of them had spent roughly 4,000 years in the soil of the Indian subcontinent, which is one of the worst places on Earth to look for ancient DNA. Heat breaks it apart. Humidity breaks it apart. 4,000 monsoons break it apart. By any reasonable expectation, there was nothing in those bones left to read. They screened all 61. 60 of them were empty. One of them held a trace. Not a good sample, a trace. A scatter of fragments, buried under contamination and 4 millennia of decay. The team went back to that one sample more than 100 times. And what they finally pulled out of it wasn't a discovery. It was an absence. This is the story of the Indus Valley Civilization, the largest and the least understood of the ancient world's great urban societies, and of what happened when, for the first time in history, someone read the genome of a person who actually lived inside it. Because for a century, we have known almost everything about their cities, and almost nothing about them. We have their streets, laid out on a grid, in cities like Mohenjo-Daro and Harappa and Dholavira, 1,000 kilometers apart and built to the same plan. We have their bricks, fired to a standard ratio and used across the entire civilization, as though somebody had published a specification and everyone followed it. We have covered drains running under the roads. We have public baths. We have a system of stone weights so consistent that a merchant at one end of the territory could trade with a merchant at the other, and neither would need to argue. And we have the strangest part. No palaces, no royal tombs, no monuments to a king, no carved conquests, no obvious temples. A civilization spread across an area larger than ancient Egypt and Mesopotamia put together, with no visible ruler anywhere in it. We have their seals, thousands of them, carved with animals and with a script of roughly 400 signs that has never been deciphered, and probably never will be. The longest inscription anyone has ever found is about 17 characters long. There is no bilingual key, no Rosetta Stone. They wrote, and we cannot read a word of it. So we have 5 million people's worth of civilization, and until 2019, we did not have one of them. Not a single face at the level that actually tells you where a person came from. Now we do. One woman. And the thing she was missing rewrote how an entire subcontinent understands where it came from. Stay with this one to the end, because the answer that came out of it is not the answer almost anyone expected, including, I think, the people who went looking for it. And if you enjoy the kind of documentary that names its sources and shows its work, subscribing genuinely helps this channel keep making them. To understand what was missing from that bone, we first need to understand the model everyone was working from. In 2009, a team led by David Reich at Harvard, working with Indian collaborators, published a paper in Nature that reshaped South Asian genetics. They found that almost every population in the subcontinent, north, south, east, west, across 1,000 communities, could be modeled as a mixture of 2 ancestral groups. They called them Ancestral North Indians and Ancestral South Indians, ANI and ASI. The Ancestral North Indian component was related to populations in Central Asia, the Middle East, and Europe. The Ancestral South Indian component was indigenous to South Asia and related to nothing else on Earth. And here is the crucial part. Nobody today is purely one or the other. Every group sits somewhere along a gradient between them. Some carry more ANI, some carry more ASI, but everyone is a blend, and the blending is ancient. Geneticists call that kind of gradient a cline. Not 2 boxes, a slope. And the position of a population on that slope is a matter of proportion, not category. That was the model. 2 streams, 1 gradient, everybody mixed. What it could not tell you was when, or how, Or who was actually standing in the Indus Valley in 2500 BCE while those cities were at their height? For that, you need ancient DNA. And for a century, South Asia would not give it up. Which brings us back to Rakhigarhi. Rakhigarhi sits about 150 kilometers northwest of Delhi in the Hisar district of Haryana. It is one of the largest Indus Valley sites ever found, and it does not look like a city. It looks like a series of low hills rising out of farmland. That is what a dead city becomes. Archaeologists call it a mound, a tell. People build, the buildings fall. People build on top of the rubble, and the whole thing slowly rises. Cut into it and you get a cross-section of time, every era stacked on the one below. Hold on to that image because it is going to come back at the end of this, and it is going to mean something different than it does right now. The Rakhigarhi excavation was led by Vasant Shinde of Deccan College in Pune. His team found a cemetery about a kilometer from the main habitation area, which is itself a Harappan signature, that deliberate separation of the living from the dead. The graves held the pottery, the semi-precious stone beads, and the copper and shell bangles you find at Harappan sites across the entire civilization. The bodies themselves were in terrible condition, which is worth sitting with for a second, because ancient DNA is not the reliable technology television makes it look like. DNA starts falling apart the moment you die. Water hydrolyzes it. Bacteria consume it. Every degree of heat accelerates it. What survives after a few thousand years is not a genome. It is confetti, short fragments a few dozen letters long, mixed in with the DNA of every microbe that ever lived in that soil and every archaeologist who ever handled the bone. In cold, dry places, Siberia, the Alps, Northern Europe, enough of it survives to work with. That is why the ancient DNA revolution happened where it happened, and why the map of ancient genomes was for years a map of cold countries. The subcontinent is not a cold country. This is why the entire prehistory of a fifth of the human species had to be reconstructed from living people's DNA, working backwards, while Europe got to read its past directly. The collagen in the bones had degraded so far that radiocarbon dating on the skeletons kept failing. The carbon to nitrogen ratios came back outside the usable range over and over, including 5 separate attempts on the individual that mattered. They had to date the cemetery by its archaeological context instead. Charcoal from the site returned dates between 2800 and 2300 BCE, squarely inside the mature phase of the Indus Valley Civilization, and every scrap of evidence at Rakhigarhi belongs to that period and no other. So they knew when she lived. They just could not get her to speak. 252 sequencing libraries later, from 61 distinct samples, they had one. She is designated I-6113, a woman buried at Rakhigarhi 4,500 years ago in the mature phase of the Indus Valley Civilization. The first person from that civilization ever sequenced. And the paper that reported her, published in Cell in September 2019 by Shinde, Narasimhan, Rowland, and colleagues, is titled with the finding itself. An ancient Harappan genome lacks ancestry from steppe pastoralists or Iranian farmers. Lacks. The headline result of the first Indus Valley genome ever recovered was 2 things that weren't there. The first absence was steppe ancestry. There is a specific genetic signature associated with the pastoralist peoples of the Eurasian steppe, the vast grassland belt running north of the Black Sea and across Central Asia. It is one of the most recognizable ancestry components in all of Eurasian prehistory, and it is present, at meaningful levels, in a great many populations of northern South Asia today. In the woman from Rakhigarhi, at the height of the Indus Valley Civilization, it is not there. Not reduced, not trace, not there. The second absence was Anatolian farmer ancestry, the signature of the population that carried agriculture out of the Fertile Crescent and across Europe. Also absent. Think about what that means for a moment. The two great ancestral movements that shaped the genetic map of Europe, the farmers coming west, the pastoralists coming after them, neither one is visible in a person living in one of the largest cities on Earth at the same time. Her ancestry was something else. A mixture of two things: a lineage related to ancient Iranian populations, and a lineage related to the ancient hunter-gatherers of South and Southeast Asia. That second component is the deep one. The first human layer in the subcontinent, laid down tens of thousands of years before any of this, sometimes labeled AASI in the literature. It has no close relatives anywhere else on Earth. So the answer to who were the Indus Valley people is those two things in combination, and nothing else. But there was more, because she wasn't the only one. Alongside the Rakhigarhi paper, the same week in Science, a team led by Vagheesh Narasimhan and Nick Patterson published the largest ancient DNA study ever attempted in this part of the world. 523 ancient individuals spanning 8,000 years. The formation of human populations in South and Central Asia. Science, Volume 365, September 2019. And buried in that dataset were 11 people who did not belong where they were found. They came from two sites, Gonur in what is now Turkmenistan, and Shar-e Sokhta in eastern Iran. Both were major Bronze Age centers. Both were in documented cultural contact with the Indus Valley, trade, goods, materials moving across the plateau. Gonur is worth a moment on its own. It sits in the Karakum Desert, in a belt of oases along the Murghab River, and it belongs to something archaeologists call the Bactria Margiana Archaeological Complex, the BMAC. Monumental walls, planned compounds, a whole urban culture nobody knew existed until the 20th century, sitting in the desert between Iran, the Indus, and the steppe. The Narasimhan team could model where the BMAC's people came from, and the answer was the same Southwestern Asian gradient that runs through everything in this story. Gonur was not an outpost of somewhere else. It was one more position on the same slope, which is exactly why the 11 mattered. At a site where the whole population sat neatly on the expected gradient, 11 people sat somewhere else entirely. At both sites, most of the buried population looked like what you would expect: local, consistent, unremarkable. 11 individuals did not. They were genetic outliers at their own cemeteries. And when the Narasimhan team modeled them, they formed a gradient of their own, a mixture of Iranian-related and South Asian hunter-gatherer-related ancestry in varying proportions. They called it the Indus Periphery cline. The woman from Rakhigarhi falls directly onto it. Read that again, because the order of discovery here is genuinely strange. We found the Indus Valley people in Turkmenistan and Iran before we found them in the Indus Valley. 11 migrants, buried hundreds of kilometers from home, were the first genetic evidence of that civilization anyone ever held. And nobody knew what they were until a single degraded bone from a Haryana cemetery gave us the reference point.
That is what the Narasimhan team means when they write that people fitting on the Indus Periphery cline constitute the majority of the ancestors of present-day South Asians. Not a fragment, not a footnote. The largest single component in the ancestry of a fifth of the human species, identified from 11 foreigners and 1 woman. And when they looked at where I6113 sits on that cline, she falls toward the Iranian-related end, which told them that this ancestry wasn't confined to the western edge of the civilization out on the periphery. It reached all the way to Rakhigarhi at the eastern geographic extreme, but even this wasn't the full story, because the Iranian-related lineage turned out not to be what its name suggests. The obvious reading is that farmers from Iran walked east, brought agriculture with them, and settled the Indus. It is a tidy story. It matches what happened in Europe, where farming and farmers traveled together. The genetics say no. The Narasimhan and Shinde teams showed that the Iranian-related lineage in these people split off from the ancestors of Iranian farmers and Iranian herders and Iranian hunter-gatherers before those three groups had separated from each other, which is to say, before farming was invented in the Fertile Crescent at all. The lineage predates the thing it was supposed to have carried. You cannot bring farming with you from a place at a time when nobody in that place is farming yet, which leaves two possibilities, and the authors state both plainly. Either agriculture was invented independently in South Asia, or it arrived as an idea, transmitted, adopted, copied, rather than carried in on a wave of incoming farmers who replaced the people already there. The people stayed, the knowledge moved, and that single finding removes one of the two great theories for how Indo-European languages reached South Asia. If farmers didn't come from Anatolia across the Iranian plateau, they didn't bring their languages with them either, which leaves the other theory. And to test that, you need the steppe. And the deeper the Narasimhan team looked, the stranger it became. Their 523 individuals came from three broad regions, 182 from Iran and the southern part of Central Asia, Turkmenistan, Uzbekistan, Tajikistan, Afghanistan, Kyrgyzstan, 209 from the steppe in the northern forest zone, mostly in present-day Kazakhstan and Russia, and 132 from northern Pakistan. 8,000 years of people laid end to end, and the steppe signature, the one missing from Rakhigarhi, behaves in that dataset like a switch. Curious, before roughly 2000 BCE, in every individual connected to South Asia that they could sequence, it is absent. The Indus Periphery cline has no steppe ancestry anywhere in it. After roughly 2000 BCE, it appears. The descendants of steppe pastoralists moved south through Central Asia, and about a millennium later, in the Swat Valley of northern Pakistan, you find the same Indus Periphery ancestry, now mixed with theirs. You can date it. That is the thing that makes this study different from a century of argument. The arrival isn't inferred from a pot, or a horse bone, or a passage in a text. It is a specific ancestry component appearing in a specific place, in bodies, after a specific time, and never before. And the Swat Valley matters because of what it is. Northern Pakistan, high in the mountains, a corridor, the kind of place people pass through rather than stop in. 132 of the study's individuals come from that region, which makes it the densest window we have into what happened on the South Asian side of this. What it shows is not a replacement. It shows Indus Periphery ancestry still there, still the foundation, with steppe ancestry layered into it.
Some of it arrived early. Some of it arrived late. Some of it barely arrived at all. And the timing lines up with something else. The Indus Valley cities decline after roughly 1900 BCE. The trade networks thin out, the urban centers empty, the population disperses east and south. What the Narasimhan team describe is what happened next. The people of that civilization mixing southeast with the deep hunter-gatherer layer to form one ancestral population, and mixing north with the incoming steppe descendants to form the other. Both at once, both out of the same starting material. And the mechanism is not what the older language implies. This wasn't an event. It was centuries of movement and mixing, running in both directions across an enormous space, involving people who almost certainly had no idea they were part of anything. Some communities absorbed it heavily, some barely at all. Some regions show it early, some late. What emerged on the far side by the Bronze Age was a subcontinent modeled as a mixture of three sources: the deep South Asian hunter-gatherer layer, the Indus Periphery cline, and steppe ancestry. Three streams, one gradient. Everybody mixed. And then they turned the map around. Because the steppe ancestry that arrived in South Asia after 2000 BCE has the same genetic profile as the steppe ancestry in Bronze Age Eastern Europe. The same profile. The same source population, moving out of one focal area north of the Black Sea, and going both ways, west into Europe, east into Central Asia, and then south. To put the scale of that in perspective, the genetic gradient running across South Asia and the genetic gradient running across Europe are not two separate stories that happen to rhyme. They are two arms of the same movement, unfolding at roughly the same time, on opposite ends of a continent, in populations that would never meet again. Two subcontinents, one event, recorded in the bodies of people who left no writing about it whatsoever. And the Narasimhan team make one further carefully worded point. That movement, they write, was likely the conduit for the spread of Indo-European languages, and specifically, it tracks the distinctive features that Indo-Iranian and Balto-Slavic languages share with each other. Not proven, likely. The authors say likely, and so will I. But consider what that means. Sanskrit and Lithuanian, Hindi and Russian, Persian and Polish. Languages that a linguist could tell you were related 200 years ago, on the evidence of grammar alone. And here is a movement of actual human beings, datable in bone, running along exactly the line that grammar predicted. The linguists were right. They just had no way to prove it until somebody sequenced 523 skeletons. So, zoom all the way out. Every population in South Asia today, north, south, coastal, inland, every community, every region, fits the same model. A mixture of 3 ancestral sources in different proportions. That is the finding. That is the whole finding. And I want to be careful here because this is exactly the point where this subject usually goes wrong. The 3-stream model is not a hierarchy. It is not a scoreboard. It does not make anyone more or less anything. Proportions are not rankings, and the moment you start reading them as one, you have stopped doing genetics and started doing something else. The data does not support that reading. It never did. What it supports is stranger and better. Go back to Rakhigarhi. Go back to the mound. Remember what a mound is. You cut into it and you find every era stacked. The first village at the bottom, the great city in the middle, the last people at the top, and farmland growing over all of it. And the question, which layer is the real Rakhigarhi, is not a hard question. It is a meaningless one. The mound is all of it. That is what a mound is. A genome is a mound, not a flag. The woman at Rakhigarhi has no pure descendants, not because her line failed, because it succeeded so completely that it dissolved. Her ancestry is the single largest component in the ancestry of 1/5 of the people alive on Earth right now. She is not a group, she is a layer, and she is under everyone. The Indus Valley Civilization did not vanish. It did not get replaced. Its cities were abandoned and its script went unread, but its people never went anywhere at all. They mixed south, and they mixed with what came from the north, and they became the subcontinent. Every one of the arguments people have about who arrived and who was already there is being had by people who are, genetically, both. And if you have ever looked at a South Asian ancestry result and found percentages that didn't match the story you were told about your own family, this is why. The story was a line. The evidence is a mound. 4,000 years in monsoon soil, 60 empty bones, one that held a trace and 100 attempts to read it. And what she had to say, in the end, was that there is no bottom layer. There is only the stack. That is the Indus Valley. Not a people who disappeared, a people who are still here, in a form we only learned how to see in 2019. If this is the kind of history you want more of, sourced, named, dated, and honest about what it doesn't know, subscribe, and I will keep making it.